Hello, and welcome to Mixture of Experts. I am not your host, Tim Wong. We have let Tim regrettably go on vacation this week, so I'm going to be doing my very worst impersonation of him. So thank you all for bearing with us this week. But I am Bryan Casey, and thrilled to be joined with three other distinguished guests this week who are going to help us cover the week's news in across product announcements, new research. This week, we got three exciting topics on deck for us. First, we're going to start by following up on a previous segment we actually had 2 weeks ago. So 2 weeks ago, we talked about the introduction of Google's AI overviews. Those things have now been out in the wild for 2 weeks, and the market reaction to them has also been at times wild. And so we'll discuss a little bit how the market is responding to for some folks, what is probably their first experience with Gen AI. Second, we're going to be talking about a model that turned itself into a bridge, the Golden Gate Bridge specifically. So Golden Gate Claude and the implications just around interpretability, safety, and how hopefully we at some point can find a different sort of bridge between plausibly useful and actually useful when it comes to some of this work around interpretability. And then finally, every week feels like it's a good week to talk about scaling laws, but with NVIDIA earnings, with Microsoft introducing what has now become on the internet known as the whale computer, and some even just of the recent discussion on the web about running out of data for pre-training. Now's as good a time as any to talk about the topic and maybe to take a slightly different approach on it that we have in the past. So today, as usual, we are joined by a distinguished group of researchers, product leaders, and engineers. I am joined by Kate Soule, Program Director, Generative AI Research. So welcome to the podcast, Kate.
Thanks, Brian.
Chris Hay, Distinguished Engineer, CTO, Customer Transformation. Welcome back, Chris.
What up?
And a newbie on the show, Skyler Speakman, Senior Research Scientist. So welcome to the show, Skyler.
My first time here. I'm looking forward to it.
So thanks, y'all, for being here. We will start with AI overviews. So as I mentioned, 2 weeks ago, Google said that they were going to roll these out across the United States, and they did, in fact, do that. And very predictably, the first thing the internet did was latch on to every single example that was funny or troubling around various hallucinations that were happening. And of course, those things have been going viral across social media. I wrote down some of my favorite examples that I've saw, which included Google recommending that the correct number of rocks to eat is a small number of rocks, that a pair of headphones weighs $350, that certain toys are great for small kids when actually they're potentially fatal. And then finally, one that I think is yet another example of some of the problems. But when asked which race is the strongest, Google said that white men of Nordic and Eastern European descent were in fact the strongest.
I had not heard that one.
That was, yes. So all of those things. So I do want to start by maybe adding a little bit of balance to this, which is like Gemini is a very capable model, actually. And the thing we're not seeing on the internet is all the things that are actually going fine and well, right? People are cherry picking to some extent examples that are particularly comical or troubling. And one of the things that I'm sort of reminded of is that Twitter is not real life, but it does feel like a different level of visibility for this content than just when it was hidden behind, a chatbot that you had to consciously sign up for. And even if LLMs are hallucinating, let's just say 1% of the time, it's more than that, but let's just say it was only 1% of the time, knowing how much search volume is on Google, that's still a staggering volume of hallucinations that are happening every day. And so, Chris, maybe you want to just turn it over to you, get your sort of initial reaction to it, and maybe just comment on, what do you think is the right way to think about this problem? Is this like a nines of reliability problem? Do people need to start treating machines more like they treat humans with like a degree of not trust necessarily, but like a trust but verify? Or do you think the market's just cherry picking examples here and like it's actually going mostly fine and it will just continue to get better over time?
So I think it's a really interesting question because we've all been doing retrieval augmented generation for a while, right? But this is really retrieval augmented generation on a global scale. And the big issue that you have here is that when you're doing the AI overviews, it really can't tell the difference between what is truth and what is satirical or made up or is a fun article. And the internet is full of that. So if we take the rock example that you had there, Bryan, that actually came from a satirical article in The Onion. But Google couldn't differentiate between that. And I think that opens up a whole thing, as you were saying there. So one of the things to be thinking about there, it's one thing for The Onion to have a satirical article and you click on that, you know it's a satirical article. But when Google takes that and then produces an overview and puts it at the top and says, this is the answer to your question, then is it Google speaking at that point, or is it really just providing a summary of what you found? And that's where I think there is a real fundamental difference on what's going on here. So this ability to really be able to distinguish what the truth is and what isn't the truth and what is really just a fun article, I think that's the challenge that they've got ahead of them. Now, if we look at something like Perplexity, they seem to have solved that problem. So I've no doubt that Google will solve that problem in time. But I think this comes down to being able to distinguish the difference of the results.
I'm glad you brought up the RAG analysis because I wanted to just jump in there. I think there is a difference between referencing incorrect information and a hallucination where the model is generating it. And I'm not quite yet sure for Google's AI overview how much of it are incorrect references from a RAG system and how much of it is really, truly novel, incorrect, but novel generated text. And I don't know if we know the inner workings of that quite yet. But there is a difference between those two types of mistakes made in these AI overviews.
Yeah, I was going to say, I'm right. And when you do RAG anyway, depending on the creativity, you're going to have a little bit of creativity anyway in your settings. So it's really how much are they going to crank that up or crank that down over time?
It's actually interesting you mentioned that because there were examples, actually the example of like the children's toy that was actually potentially a safety hazard and fatal if swallowed. The funny thing is like there was a thread that went like somewhat a little viral about that. And then the first post in the comment section was actually somebody referencing like the #1 result on Google and had almost that content verbatim in there. Yeah. And then, but what was interesting is when it was Google showing the result versus it just being a link on the internet, the reaction to it was totally different. When it was Google, it was this like massive, crazy problem. When it was just the fact that this was the first result on the internet, people are like, oh, well, it's just content. And that happens all the time. And people have to know to not trust that stuff. And so people do seem like they're approaching this with like different expectations than they would normal content.
I think people are assuming, like everyone is kind of cued to assume if they're reading this like statement that appears almost like it's a fact and it's just, saying this is what the facts are, that there's been some sort of due diligence and like reasoning that's gone on to evaluate and to look through. And, that's not quite how these systems work, at least not yet. So, I think there is a degree of skepticism that's going to be needed for the near term when looking at these types of results and working through them, making sure that just because, as Skyler, you pointed out, right, just because, it's on the internet and it's being shared doesn't mean it's a hallucination. It just means this is an example of what's on the internet.
Actually, one question I wanted to follow up on specifically on that touches on, I think some of the stuff that we were even talking about maybe on the show last week, which is just around UX. And so one of the interesting things is that the place in the page that an AI overview is taking up is a space that was traditionally occupied by a thing called the featured snippet, if you live in the search world. And where Google was sourcing that data historically was just one of the top 2 or 3 most authoritative and widely cited results on the web. And that would be taken verbatim and placed in the snippet. Google's now putting their AI overviews in the exact same place on the page where that content used to be. And, it struck me that maybe one of the challenges there is that people are not necessarily treating the content as having been sourced totally different from one another. It's in the same place, in the same page, so they think it's the same. And one of the things that started to make me think about is, when we think about, and Kate, maybe you could take this one, we almost have these 3 different types of things, which is like human-generated content, LLM-generated content, and then traditional answers from like a calculator or a machine like that you can like almost trust 100%. And do you think that we actually need to do more in terms of distinguishing the user experience between those things, right? Rather than merging it all together and like deeply embedding LLMs and AI into everything we do, like making it very clear to users, where they're seeing, features and content that are sourced differently than they have been historically.
Absolutely. And I think it goes beyond just even like consumer use cases. It's super important for just regular consumers doing Google searches, but especially when you look at enterprise applications and other things, the theme of like being able to cite your sources and being able to decompose a bit what is going on inside of the black box, I think is increasingly going to be critical for any sort of real adoption, being able to move beyond like, okay, this is a fun toy to this is something that I can actually use in the day-to-day. So I really hope that we start to make some progress there on some of these more consumer-friendly chatbots, because in the enterprise setting, that's becoming increasingly the norm. Like in RAG patterns, you want to return, here's the source where I, got my answer from, and that's becoming increasingly important.
One of the things that opens up in my mind, Kate, and it'd be interesting in your perspective there, is that's kind of fine from a web interface where you're getting your result, you get your overview, and then you've got all the links and here's where I reference. But as we talked about in a previous episode where we're moving into multimodality and you're going to be chatting with arguably a human voice at that point, right? You're probably not going to want somebody going back and say, this is the answer to the question. And by the way, I got this answer from here, and you can visit it on XYZ, blah, 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 because you're going to switch off at that point. So I wonder what the best user experience for voice for that sort of helpful chatbot, but also being fair and transparent that it's AI generated.
I honestly question if chat, regardless if it's with voice or text, is the right domain here, like the right mechanism and mode for this type of analysis. And one of the things I'm really excited by the AI overviews is it seems like one of the first use cases that is really taking on, that's consumer focused, where it's not a chatbot, right? Where we're using generative AI and we're able to start to drive information distillation and gathering lots of different sources and providing results, without having to like have a multi-turn conversation, like asking, are you sure about this answer? Where did you find it? Like, can you give me more sources? Like, that's a very unintuitive flow, but I think we've been so trained on chat to equal generative AI up until now that that's just how we all assume it has to work. So I would actually say, I don't think, voice and other things are where this hopefully is going. I think there's a lot of opportunity to think through what do new types of non-chat based applications look like, and how can we embed those decision-making criteria and sources and other things that are needed to really drive value along the way without it being this like multi-turn interrogation of an agent.
What do we think Google is collecting on the usage patterns of these? Way back in the day, they would have search and they would obviously collect click-through, right? What are you clicking on? Any guesses as to what sort of metrics Google's collecting as people interact with these AI overviews? That's not in my space at all. I'm just wondering if I'm guessing someone in there is watching how we are interacting with the AI overviews presented to us.
Ironically, this is the one question I'm qualified to answer. And so, at least when Google first introduced AI overviews had been in beta for a while, and they said they were bringing in prime time. And two of the things that they talked about were that, and they were really messaging to publishers because like publishers have been hysterical about the impact of this. And like what's been really interesting is that the impact on organic traffic to publishers has been like almost negligible. So everyone thought it was like the end of the internet, and then like almost nothing happened in terms of traffic. But two of the things that Google said was, one, that the content that was surfaced through AI overviews was actually getting more click-through and more traffic than the stuff that was present in just the normal SERP. And the idea there was that those links was presented with more context. I think Sundar did another interview not long after that where he was talking more about like generative UIs, and you can just see, I think, more about like how you turn a query, a user query, and you generate a UI that places like links and information in context better than just like a flat list, which is sort of what they do. They would say they do not do that today, but it's like there's still some of that. And so that was one thing. And then the other thing that they talked about, I'm sure they measure more things, but the other thing that they measured is, do the people who are exposed to AI overviews start using search more? Like, is this something that increases their usage of this product over time? Because the other audience that is terrified of this is obviously like shareholders. And people want to know, it's like, are you going to kill search? And in the process of doing that, where's all the ad revenue going to go? And so one of the other things that they're very clear about is like, oh no, people who get exposed to this actually use this product more over time. And so I think they're reminding some of their other stakeholders a little bit there, but those are at least some of the ones that they've publicly discussed. Last week, Anthropic released a novel version of its Claude 3 Sonnet model. And this model did not believe that it was a helpful AI assistant. Instead, it believed it was the Golden Gate Bridge, which is a fun thing to have happened. But really, that was a demo of research that Anthropic has been doing for a long time, and really the industry has been pursuing for a long time, which is in the space of interpretability. And within the space of interpretability, Anthropic's been doing a lot of research around mechanistic interpretability. But part of the problem in this space is that, I think, Kate, to the comment you made earlier, is that these models are a black box today. You know, you put a pile of all the data in the internet and linear algebra and outspits something that somehow appears to know a lot about the world, but nobody knows how that's actually happening, like not really. And so interpretability is a space that's trying to answer some of those questions. And what was interesting and why Golden Gate Claude was important was that Anthropic demonstrated that they could identify the features within the model that activated when, either text or a picture of the Golden Gate Bridge was presented. So they knew kind of the combination of like neurons and circuits that would say like this thing represents the Golden Gate Bridge. And perhaps even more importantly, that by dialing that feature up or down, they could influence the behavior of the model to the point where if you dialed it up high enough, model thought it was the Golden Gate Bridge. And this was, if you read the paper, wasn't the only example either. And I'll share one other one, which is that they had another feature that would fire when it was looking at code, and it would detect a security vulnerability in the code. And they had an example too, where if you dialed up that feature, it would actually introduce a buffer overflow vulnerability into the code as well. So when you think about the ability to dial features up and down within a model fairly surgically, pretty important in terms of the steerability of the model potentially. And certainly, I think you can understand a little bit why folks in the AI safety community in particular have been focused on this interpretability space. So I personally find the space super fascinating. And Skyler, I just want to turn it over to you to maybe kick us off a little bit to just maybe even talk about like your general reactions to the paper, maybe, and like the demo as a starting point, and just like what you found interesting, like how important you think it is, and just, maybe talk a little bit about how, I don't know, what you thought of it.
Yes, great. I'm happy to talk about this space. Without droning on too long, I have to describe what I do to my kids, 10-year-olds, 7-year-olds, and they know that I work with AI. And their understanding is text goes in and text comes out. That's their kind of view of these large language models. And where I try to tell them where I and our team work on is actually in between. What happens to the text when it goes in? How does it get manipulated? And then it gets spit back out. And I think this has been coming out as an area called representation engineering. And I would call this paper, the Golden Gate example, a great example of representation engineering. They're not manipulating prompts. They're not coming up with a new metric of how well their model's performing. They are messing with the representation of the model. And I think that's just a really cool, I would say, emerging or perhaps even underrepresented area of research when you compare it to prompt engineering, for example. How can we, probe the model, how can we prompt the model in such a right way to make it be convinced it's a Golden Gate Bridge? That would be a very different approach to what they had done with this Golden Gate example. It's a fun example. They took it down. I think it was only available for people to use for about 24 hours.
Yep, 24 hours.
And so it's already been with us and taken away too soon. But I think for me, the what I would like to get around to the larger audience is they did not just create a new large language model by training it only on Golden Gate Bridge data. They did not insert a little prompt that says, every time you answer a question, pretend you're the Golden Gate Bridge. they really did identify the inner workings of these models and then crank it up, as Bryan had described. And I think what I'm excited about that is in this representation engineering space, it doesn't take the latest, greatest technologies to find these cool insights. Things like principal component analysis, things like a sparse autoencoder. These things were, decades old or a 10-year-old analysis, but applied to the inner workings of these large language models is now this new rich space of representation engineering. So I like the paper both for how it presented its work. Chris Olah, one of the authors, is a visualization genius, and in their publication, they've got some really, really cool visualizations of what they found out. So I think that's probably my first takeaway I'd like to spread to a broader audience, that large language models are not just text in and text out. There's a lot of rich science to be done in that representation space, and the Golden Gate Bridge paper is a great example of that.
That's great. Can you maybe talk a little bit about the safety community? I think in particular is very interested in the topic of interpretability, and I think feels some level of urgency around it, given how capable and how quickly capable some of the models are becoming. But maybe just can you talk a little bit about why it's so important to the safety community, and then maybe also talk about like other applications and domain areas where this space of interpretability promises to it could be on the capability side of it, but just other places where we think interpretability will make a difference.
Right. I think a real clear example, I was reading of a blog after Golden Gate Claude has been brought down. Some people noted that when Golden Gate feature was highly activated, when Claude 3 was turned into Golden Gate Claude, he would respond to tasks that he was previously would not. So please, can you write a scam email? Normal Claude would respond, sorry, I can't do that. Golden Gate Claude would proceed and it would generate this scam email. Nothing to do with that Golden Gate analogy, but it was an example of when you mess with these other features like that, there are other sort of perhaps previously thought built-in guardrails that are no longer as strong. And so I think that's going to be another really interesting area of work of you may have well-intentioned people manipulating these features. We don't know what other guardrails that previously worked will not work after you've manipulated a feature, because who would have thought that amplifying the Golden Gate idea, the bridge, would make the large language model Claude more likely to comply to an illicit task. So I think that was just, an example that I had read about there, that I think the safety community, they might not care about a large language model identifying as the Golden Gate Bridge, but they will definitely be interested about the jailbreaking behavior of what happens when people start manipulating it.
Skyler, I got a question for you based off of that. Like, what implications does that have then for open sourcing models and releasing models and weights? A lot of times model providers do a lot of safety, reinforcement learning, and other protections on top of the models that are before they're released to help manage some of those behaviors. Like, could you see some of that now being at risk and eroding?
The willingness to open source, is that what you mean by being at risk? The willingness for companies to open up.
Yeah, take it as you will. Willingness for companies to open source, the risk that is introduced from releasing model weights that now can be, shall we say, exploited in ways that weren't originally anticipated by the model designer and builder?
Really good question. Actually, Anthropic themselves, they have this much larger blog you can read where they defend why they have not open sourced these types of their models in that regard. I imagine people around the AI community right now, probably over the weekend, are busy running their own version of Golden Gate. They're going to find their own features. They're going to start manipulating those. So I think we'll probably see some of those results showing up, hopefully on archive or maybe on blog posts within this week.
On that, Skyler, so I did a YouTube video about 3-4 months ago where I took the Gemma model and I took the Mistral model. So it's not at the feature level that they did. And what I did is I lopped off the input embeddings layer, right? So I left the model only having the input embeddings layer, nothing else. And then what I did is I ran a cosine similarity search against the various the various tokens within the input embeddings layer. And then just did a visualization, looked at what embeddings were close to each other. And when I did that, it was incredible. And you can go check out that YouTube video, but it was incredible. So you would see that just in the input embeddings layer, nowhere else, you would see that misspelling of words were super close to each other. So if I had London with a capital L and London with a small l, or London with a space after, they would all cluster together. But not just that. Cities themselves would cluster together. So you would see London, you would see Moscow, you would see Paris. And in fact, you would see almost a distance similarity in the visualization, which was fascinating. You saw the same thing with celebrities. They would cluster together. Computer programming terms, right? So, the various for loops, a for loop, a while loop, etc. So for, while would all come together. Now, the reason that I ran that against the Mistral model and the Gemma model is the Gemma model has got a vocabulary of something like 256,000 tokens, whereas the Mistral model has got 32,000 tokens, right? So there's a lot of splitting of tokens in Mistral, but in the Gemma model, there's not a lot of splitting, right? So it means that you got a much closer on the similarity. So when I did that, I was absolutely blown away. And like the Anthropic team, I wanted to go to the next layer because I had the same theory that if I jumped down the next layers, you would start to see these features activate because I could see it already just in the embeddings layer. And one of the theories, and I'm glad to say I think I've been proven right, is that you may have noticed that as new models are coming out, everybody is increasing their tokenizer vocabulary. Everybody's increased their input embeddings layer. And the reason is, I believe, is it's easier for the models to be able to generalize more as it goes up the layers if you get that pretty close on the input embeddings layer. And I think, therefore, when I looked at the Anthropic paper bringing it back there, I could visualize when it talked about cities, when it talked about locations, when it talked about computer programming terms, I was like, I could see that just in the input embeddings layer only on my visualization. So I can absolutely see how that would then translate into features as the models get stacked up and it becomes richer and richer with semantic meaning.
Yes, I'm going to geek out here a little bit. The official papers of the Claude Golden Gate work are all plays on the word monosemanticity, which is basically a really big word that is getting the idea at, can we find a single part of these huge large language models that have one meaning? And they were able to do that for the Golden Gate idea. And then the idea was, now what happens if we take that one part of this huge large language model and crank it up tenfold, and then you get the idea of Claude large language model. But Chris, your description of how these types of words or tokens are coming together like that, the tech behind Claude's Golden Gate basically, okay, weaponized is a bit dramatic, but it really emphasized, can we take this richer embedding space and create a million features from it? And then once they had those features, you get the ones like the Golden Gate and your security concerns, and I think there was one on tourist attractions, et cetera. But it's getting at this idea of, can we find a montosemantic part of these large language models? Again, exciting space to be. Again, and now I'll come back. I love it when the research gets into these inner workings of large language models. I think that's fascinating.
So, also last week was another big week of announcements across the industry. But I actually just want to use Microsoft. I mentioned, introduced what has become known as the whale computer on the internet, because they used this analogy of marine life to basically explain the orders of magnitude size of the infrastructure building the sport AI workloads. And they used these 3 steps of shark, orca, and then a whale. And what's funny is just if you look at like this morning, I was like Googling how much does a shark weigh? And so sharks are roughly, I think like 800 pounds. And then an orca is 8,000 pounds. And then a whale is like 80,000 pounds. And so it's just an order of magnitude. And they were thinking about like, okay, what's an interesting and fun way to visualize and communicate an order of magnitude? And maybe a little bit memeable in a way. And so they certainly achieved that. But in some ways, it's just like classic scaling laws, right? It goes back to the original 2020 paper that says, you know, if you're trying to improve the capability of these models, reduce the overall loss in them, that you want to increase your compute, your data, your parameter count by roughly similar orders of magnitude and from one generation of the model to the next. And that improves the overall sort of general capability of the thing. And that's, you can look at NVIDIA earnings, like that's held pretty true up to this point. But maybe where I wanted to jump in is, Kate, a comment you made, I think it was last week on the show, where you're saying like something to the effect of saying enterprises may not, for a lot of these use cases, may not need a artificial general intelligence. They actually may not need all the capability that exists right now. And so, you know, I think it'd be great if maybe you could talk a little bit about, you know, maybe a little bit about the scaling laws, but a different perspective of like that. The scaling laws idea to me is really from the perspective of if you're a model provider trying to build AGI. It's not if you're an enterprise trying to get ROI, essentially. And absolutely. Yeah, can you talk maybe a little bit about just some of what you see in terms of like the cost and size trade-offs and, you know, does bigger mean better all the time?
I mean, I think what the scaling laws, as you say, do a good job at is for model providers, like people actually training these large models. And what was really kind of one of the big breakthroughs is, look, you can't just increase your model size. The most efficient way to improve performance is to also increase the amount of data that's used as well. And just because you now know maybe let's call it the most cost-effective way to train a model of, you know, the nth degree in size, does that mean it's economically incentivized to train that model? Will the actual benefits that you derive from that model justify the cost? That's an entirely different question. That's the scaling laws don't answer. So I think to this point, there's been enough excitement and clear use cases and value where there's been a clear economic driver to support, okay, we need to train some bigger and bigger models. And that's gotten to us where we are today. But, you know, I do question some of the statements and claims out there about, you know, how we're always going to be, you know, we have to keep investing and build bigger and bigger models. I'm sure there's always, you know, I'm going to put like the science of it aside of exploring and determining what's next. But if we look at what's actually economically incentivized, I think we're going to start to see performance plateau. And we look at what the real use cases are and the value drivers. I don't think we're going to need models that are 100 times bigger than what we have today to extract most of the value from generative AI and a lot of the low-hanging fruit. So, you know, I think it's still a huge area of exploration. If you kind of look at even scaling laws themselves keep changing, you know, it's still this concept of you need more data for bigger models. But I'm hopeful that we're going to start to see more work built in on, you know, what will be economically incentivized to build, as well as looking at other costs that aren't reflected in these scaling laws. Costs like data. You mentioned, you know, concerns about pre-training data disappearing. So if we need more data to train bigger models, you know, at some point we're going to run out of, quote, real data. And so that's a whole different frontier of looking at data costs, looking at what role synthetic data could play, and that all of that really needs to be explored. There's also costs on like climate and, you know, the actual compute costs and, you know, are those costs going to start to be better realized in the costs that are charged to model providers and people leveraging these models? And, you know, I think all of that will maybe start to change the narrative a little bit of where the future is going as we continue to learn more.
Maybe one follow-up to that is I remember the reaction in the market when the Llama 3 models came out. the 8 billion parameter model in particular, which I believe is trained on 75 times as much data as you would if you were just trying to do an optimally compute efficient model, which obviously is not the approach that they took. They instead took an approach of trying to build something small and capable that you could run on your laptop that was cheap for inference, but still had a ton of capability. Do you see like more of that happening?
Definitely. So right now, again, the main scaling laws that everyone's using are for model providers, not thinking about necessarily. So this is another cost that isn't yet really reflected, the model lifecycle and the full usage. So like think about your fixed costs of how much does it take to create that model once versus the marginal cost to use it every single time you run inference. So you're incentivized to build smaller models if you're going to have a long model lifecycle and you're going to hit that model millions and billions of times and run inference on it. You want to get that, marginal cost as low as possible. And that's where the llamas are going. That's where, like if you look at the Phi model series as well, they're training on these incredibly data dense ratios of amount of data per token, where like Chinchilla, I think, calls for like 20 to 1, 20 tokens per parameter, something like that. They're now in the hundreds and thousands of tokens per parameter. So I think we're still really also understanding that trade-off. And I think we'll continue to, that's where everyone is headed, understanding that there's, maybe it hasn't been articulated fully in a scaling law, but trying to optimize that total life cycle of when this gets deployed, we need to be able to run it as small as model as possible for this to be cost effective.
And I think, Kate, to that point, I think one of the questions you need to ask in general is how much reasoning do you need from your model? So if I like to use the cooking analogy. So if I go to a Gordon Ramsay restaurant and I'm not expecting Gordon Ramsay to cook my meal for me, right? And I'm not expecting him to invent a brand new meal there and then. What I'm wanting is a recipe that he's invented at some point, and then there's going to be some like sous chef or something that's going to cook up that meal, and I'm going to serve it, and I'm going to have the Gordon Ramsay experience. And I think when you're looking at the larger models, with hundreds of billions of parameters, even 70 billion parameters type models, you're asking for the Gordon Ramsay there. You're asking for, I want you to come up with the recipe. I want you to invent the recipe, cook the recipe, and serve me the meal at the same time. But actually using the bigger model to do the reasoning, right? Figure out what the recipe is, what the good answer is, and then passing the pattern onto the smaller model to go and do the sous chef thing. And I think that's really the big question for people when they're sort of doing POCs and they scale to production. They use the bigger models to begin with because they're trying to figure out what the answer is. But then in production, they need to, as Kate beautifully said, right? You need to keep the costs low. So they then switch to the smaller model because they want the increased latency. They want the decreased latency. They want the lower cost. But the pattern has been figured out, and you just want that smaller model to rinse and repeat, which it's really good at.
Absolutely. And I think another area, so there's this concept of like use bigger models to teach small models. And that also throws in some squirrely math with scaling laws if you need a big model to get a good small model. But moving past that, there's also, I think, a real opportunity of like model routing and figuring out what tasks do you actually need the big model for? Like when do you need, it's Gordon Ramsay to tap in versus when can you pass this off and maybe you just need to go to McDonald's for a quick bite to eat. Like this is something really easy, low value, not worth spending, an insane amount to accomplish. And that's again where I think a lot of what will be economically incentivized comes in is figuring out like how much are these tasks actually worth to you? And if you can get away with a reasonable performance with a 10 billion parameter model or a 3 billion parameter model, it's not going to be, no one's going to pay to send it to 100, multi-hundred billion, trillion parameter model instead.
Maybe one final question on this topic. And it was funny, there was an interview where people were talking to Jensen and they were asking him his opinion on how much he thought this would hold. And they were poking on things that were about really the TAM of NVIDIA, like sort of long term. And he paused because he was like, I should not answer this question because, like anything he says is like the stock price is just going to go all over the place, essentially. But, he started to talk about the opportunity being the entire I think it was $1 trillion data center market is what he was talking about. And there's been a lot of discussion about whether like all workloads will become accelerated workloads going forward, and just for every application, for every company, just the blend of stuff that they're doing on traditional CPU versus more accelerated workloads, and how they hand off between those two things. And, I'm just curious, maybe even Chris, from your perspective and just a lot of client conversations that in scenarios that you're working with, how people are thinking about that. Like, I know a bunch of inference is still done on CPUs today, but I think for some of the really low latency examples, people are talking about like, oh, do we need to put more of this on GPUs? So I'm curious how, from an application perspective inside of an enterprise account, how people are thinking about just inference and like application architectures, and how they're doing trade-offs between kind of CPU and GPU computing.
Yeah, I think it's a really interesting area. So a lot of customers are actually thinking about this all the time. So it's an architectural consideration. It's just like any other NFR. Am I going to go SaaS here? Am I going to go on premise? How do I play my cost? What am I going to do? What's the safety on that? If I'm honest, most enterprises are being pretty cautious, right? They want to do a classification task. They want to do a summarization. They don't want the model to make up some classification. They know what their list of 30 classifications are. Go do that. They know what their examples of summarizations are. Go do that. So they want to take that low-hanging fruit, and they're approaching it quite cautiously. I think where that probably changes in time, and again, it's more of a discussion for a future episode, I think, is when we move into agentic workflows, right? How do I then start to organize my information within my enterprise so the AI will have access to the right knowledge bases? Which tools will it have access to? Which is a much wider architectural discussion. So a lot of clients are starting to think about how Gen AI fits into their overall enterprise architecture, and how you need to evolve your traditional architecture for the AI to be able to use that. And again, but it's quite a slow path. But generally, I don't think things have moved on too much from classification, summarization, et cetera. And then, of course, code generation is a big productivity lever that everybody's kind of leaning into just now.
One maybe final thought on the scaling laws that I wanted to bring up is a lot of these scaling laws are also assuming the class of technology remains the same. We talked about, okay, these are scaling laws for model providers, basically in search of AGI. But like, do we really believe this class of technology is what's going to unlock AGI? I think there's a lot of thought out there that probably not. If you look at how these technologies evolve, there's a curve, but that curve is driven by multiple different technologies coming in and introducing their own mini curves on top of that. And, AGI, human intelligence requires far less energy for the amount of power and decision making. So if we're really talking about like, okay, we're going to promote these scaling laws because, model providers will be, maybe the business use cases aren't going to be incentivized, but if we can unlock AGI, it will be. I would maybe also argue that these scaling laws probably don't reflect whatever technology would converge on for AGI might scale at. So it's still a bit of an unknown.
And on that point, Kate, imagine a world where we did have AGI or even ASI at that point, right? But then you took that super intelligent being, and then you said you don't have any access to documents, you don't have access to any tools in your organization because it's all locked up in somebody else's hard disk or a box folder or something. How effective would that AGI be in an organization? I don't think very effective. So right. I think, I think
you're reading between my lines, which is AGI really actually ever going to be incentivized, at least economically? There's a big question mark there, I think. But
I think as soon as AGI is achieved, if it's achieved, it's going to be put in a box, and we're all going to go to the AI zoo, and we're going to be go and look at the AI zoo and have a chat with it. That's what I believe AGI's first task is.
What is the TAM of an AGI zoo is what we need to answer on next week's episode. So I know we're basically at time here. Thank you all for joining us on this week of Mixture of Experts. And we will be back next week, same time, not the same people. You suffered through one episode of me. I'm out of here. Tim will return. But thank you all for both joining today and for listening. Kate, Chris, Skyler, thanks all for joining today.
Thanks so much.
Thanks, Bryan.
It's been a lot of fun, man. Thanks.